So in section 8.2, we continue to look at parametric equations, and what you'll find that often you'll have sine and cos and tan involved in your parametric equations. More often the sine and the cos than the tan, but certainly trig identities tend to crop up a lot. Now the reason for that is this t, we've said we could think about it as an extra value added to the curve, right? So one thing that might be useful, now this isn't always the case, but let's say I've got any curve here. This point here I've got the x value and I've got the y value. Sometimes it's also interesting to think about this angle here, the angle between the point and the x-axis, if you see what I mean. If I draw a line from 0 to the point, what's that angle there? So often, not always, not every time you have an x and a y with sines and cos and tans as their parametric equation, but often the t is that angle there, and that tells us a bit more about the equation sometimes if we look at it in the right way. That's not really information that we tend to use at A level. At A level we just tend to have these equations and do various things with them, but often that's what's going on in the background when the person's writing the question, is that that's what the t is. So yeah, so often it's that thing there. Now then, what can we do with this? Well, this is important because of the following. X equals sine t plus 2 and y equals cos t minus 3. Now I remember when I was first taught parametric equations, I was thinking, well, okay, I need to get rid of the t. So what I do, right, is I take the equation for x and I'm going to rewrite that as x minus 2 equals sine t. So sine inverse of x minus 2 equals t. So I take that and I'm going to substitute it into equation 2, and I'm going to write y equals cos of sine inverse of x minus 2, take away 3, and there is a Cartesian equation, right? Now, I mean, it's not wrong. Y does equal that, but this is a completely useless Cartesian equation. I can't do anything with this. It's too messy. I don't know what this looks like. So I need a neater way of doing it. And the neater way of doing it, as you might have guessed, is to use tricks that we know about trigonometry already. So in this case, what I'm going to do is I'm going to say x equals sine t plus 2, y equals cos t minus 3. I'm going to rearrange this one so I get sine t equals x minus 2. I'm going to rearrange this one so I get cos t equals y plus 3, and I'm going to say sine squared plus cos squared equals 1. So if I square this one and add it to this one squared, then sine squared plus cos squared equals 1. X minus 2 squared plus y plus 3 squared is going to be on my right hand side, and now I can recognize that as the equation of a circle. Okay, so I need to use some sort of clever tricks. The clever tricks we can use are, if you can get sine on its own in one equation and cos on its own in the other equation, we can use this trick. Actually, probably doesn't get used all that much, if I'm honest, but there we go. The other trick we might want to use is to get sine on its own and cos on its own. Maybe we can do sine divided by cos and get tan, but then we're still going to have a tan of t flying around. You know, it's something that sometimes is useful. More often, what we'll do will be something like in example 4, and this is a very useful trick now, I think. X equals sine t and y equals sine 2t. If you've got a sine t or something in terms of sine t, or a cos t or something in terms of cos t, you tend to sort of leave that one alone, and let's deal with the other one. So y equals, or sine 2t is 2 sine t cos t, right? And then what we're going to do is we're going to say, well, cos t is the square root of 1 minus sine t squared. Okay? Now the reason that this is useful is because, I know that x equals sine t. So I get 2 times x square root of 1 minus x squared. Okay? So in other words, the technique in general is, if you've got x equals sine t or x equals cos t, then take y and rearrange it so that you've just got it in terms of sine t. So it's something to do with sine t, it's some function of sine t, and then replace the sine t with the x. Now that technique seems to come up quite a lot in the kind of questions the exam board like to ask. All right. Now from this point here, we might want to leave it like that. We might want to sort of try and rearrange this so it looks a bit nicer. We could square both sides, for example. Y squared equals 4x squared 1 minus x squared, or something like that. Now the point of me saying that is that you can't always get a Cartesian equation of y equals a function of x. Sometimes you have to end up with y squared and x squared linked. So this one up here, look, this is a Cartesian equation, even though it's not y equals and then a formula to do with x. So your Cartesian equation, you leave it in sort of what seems like the nicest form, all right? And yeah, I think that's all there is to say. Good luck with exercise 8b.